Hello, I'm Michael, and this is my messy kitchen counter. I'm going to show you a clock. Why a clock? There's a million of them already. True, and I made another one. But I'll show you a few cool things you can do with a clock using an Arduino Nano ESP32. It's right behind me, as you see. So we're going to have a look at the code. And to do that, we go to Arduino, Internet of Things, and we look at the clock. Now, first of all, what you see is I've linked some variables. There's a flag that says whether it's active or not. The clock can return the temperature to me, the last update in NTP time, whether NTP updated properly, and what the device's uptime is. So all that is working as we speak. It's actually working because you can see that the active flag is going between true and false. All right, it is an Arduino Nano ESP32, which is why we're connected to the Internet of Things. And let's look at the sketch for this particular clock. So let's go to the full editor. I prefer to work with the full editor. Let's have a quick look. First of all, it's important, I think, at the beginning of every project to have a section that tells you about the project, what version is it, what still has to be done, what's the date. I also include links to people that I took things from. One of the great things about this clock is the wonderful font, and I took it from Giovanni Bernardo, and he's linked here. Also the MD Parola and MD Max libraries. Those are the libraries used to drive the 8x32 LED matrix display, and I credit those as well. So all that housekeeping is in the top section. Then we get the includes and definitions. As you see, my sections in the code are very well delineated, so includes and definitions. First, the Arduino stuff that Arduino puts there, I don't touch it. Then my own stuff, so up to here is Arduino stuff, then my stuff. Libraries to do communication, excuse me, using I2C with a clock, to include the actual clock, to load a library that converts epoch time or internet time, which is a very long string, to hours, minutes, month, year, date, and so on. Then a whole bunch of stuff for the scrolling LED display. The source code is in the manual, which is linked in the project. Very important. Then the stuff to turn on the display or to define the display. Then the stuff for the timer. There is one button. One of the unique things about this clock, there's one button only, a push button on the back to set everything, to set the time, to set whether NTP, the Internet Time Mechanism, is used or not. If not, it uses its own built-in clock. Excuse me. And to see whether it needs to be set or not, whether you are setting it. So everything you do, and the GMT offset. So everything you do is set by that one button. There will never be anyone in my project looking and wondering which button should I press, if I can help it. Then we have some clock stuff. Some of this is for future use. It's very important to do two things: to document your code well, and everything is documented pretty much, and also to be future-proof. So if I know that at some future time I might want to display other messages, then I might add an array for it right now. After all, I'm not short of memory in this device. It doesn't matter. If I were short of memory, I would remove all this stuff for future use. But I'm not. We have counters. Very important never to use delays in your code, at least not in the loop. In the loop, all you should ever use is counters where you display, where you set a counter to millis and then let it increase and then see if it's beyond a certain value. Like if millis is now 1000 milliseconds more than the 1 second counter, for instance, well, then obviously the 1 second counter needs to be activated. So you do your stuff that you need to do once a second, and then you set the 1 second counter back to millis again. So I have a 1 second counter, a fast counter, a minute counter, and an hour counter. I have a flasher, that is the flag used for the colon in the middle between the hour and the minute. That flashes on and off once a second, or on once a second and off once a second. And there's various other things here to hold variables and so on. Changeable things that I think I might want to change easily and quickly and with some regularity possibly, I put in a section called changeables. And right now in my changeables, there's the sleep time and the wake time. This clock automatically dims itself at 11 p.m. and brightens again to whatever I set it to at 7 a.m. Those times can be set here. Temperature offset, that's individual as well. This clock has a thermometer 2 degrees Celsius too high, so I'm compensating for that here. Excuse me. Then we get the setup. First, again, the Arduino Cloud stuff, which I don't touch, because Arduino Cloud sets that, and so I might as well leave it the way Arduino Cloud wants it. Then I go and do my own stuff. So I initiate the wire library, that's for communication using I2C. I allocate some memory because some settings, notably whether NTP gets used or not, are stored in permanent memory, so that if I turn the device off and on, it still remembers that. Now I set the intensity, the brightness of the display. The display can be set to a brightness value between 0 and 15, but I have a pot on the back of the machine that I can set, and depending on how I set that, that translates to values of 0 to 8 only. Why? Because 8 is more than bright enough on this display. It's always nice to under-dimension things a little bit, or rather over-dimension them, and use less than you have available. So if I can make it very bright, let's make it half that brightness, because that is plenty bright enough. And it's always nice to run things not at their maximum. Then I have some counters that are now set to 0 or to the millis. I set the pin modes of the push button and so on. Excuse me. I decide if NTP is used. I read the EEPROM, the permanent memory, and all right, I go into the loop. In the loop, I do something 10 times a second, namely I update the Arduino Cloud. Arduino puts that at the beginning of each loop, so you're going to do it 80,000 times a second. I don't like to do something 80,000 times a second that could potentially be communicating with the back end. So I'm doing it 10 times a second instead. Then I have the once per second stuff, and that is things like calculate the uptime, toggle the colon flashes, so turn the colon on or off between the hours and minutes, check if the brightness has changed, and display the time. Then once a minute, I check NTP, but only for the first 5 minutes. So I check the time with whatever Arduino has set the time to, which is NTP time. And after that first 5-minute period, I check it just once an hour. And then the rest, well, the rest is very simple. There's only 2 things going on here. This section here is very important. With this particular display with the Parola library, you have to do this constantly. If you don't, nothing is displayed. So you need to be in a loop where you're constantly running this particular bit of code. And then I have all the logic to see if I'm pressing the push button, and if so, is it being pressed for the long press, so it needs to go to setup mode. And that's the end of the loop. Then I have the functions. The way this clock displays the time is very complicated due to the use of the Parola library and the fact that we're using this display. First, you get the time. You read it from the real-time clock, which is or isn't set to NTP time. Then you store it in a variable. Excuse me. There's a function using a pointer. Then you display the time. So that's all explained here. It's complicated, but with the explanation, it is all very manageable. You read the time for the clock. That's another function. Now I have time functions here for storing into the variable prior to displaying the time with the colon, the time with a smaller than symbol. That means, by the way, that's used in setting, when I'm setting the hours. When I'm setting the minutes, the colon changes to a greater than symbol, so it points to the minutes. Excuse me. And storing the year, the month, the date, the GMT offset. What is that? Well, NTP time is GMT time, or UTC time, so the time in London in winter, basically. That can be used or not. If I'm using that, I need to set my own time zone. And then here's where it calculates that, and it subtracts or adds hours to GMT time to get to your local time. That time zone is one of the settings, right? And then here is where we display the time, the year, the month, the date, and whether the NTP is on, and what the time zone is. Setting the clock, that's a long function, and that happens when you press the button for more than 4 seconds. It goes first into the hour setting. Now, at the moment it goes into that, you're already pressing the button, and it checks whether you're pressing the button and increases the hour by 1. So I first decrease the hour by 1, and then it goes into that setting automatically. It increases it, so you get back to the real time. When you don't do anything for 4 seconds, it goes into set the minute, so it displays the minute and you can set it. And then when you don't do anything for 4 seconds, you get the year, then the month, then the date. Those are not currently used, but they will be used if I decide to add summer and winter time or daylight savings time. Then it displays whether or not we're using NTP or not. So that means whether we're setting the time according to the value it gets from the internet or not. And you can toggle that. And then your time zone, your offset from minus to plus 12 hours. So that can be your offset, minus 12 to plus 12 hours. And then it goes back to normal time display. And then finally the function to set the clock to the NTP time if you're using NTP. There's a bunch of little logic there. It's very straightforward. Excuse me. You get the time from Arduino. That's the important thing. That goes to a variable epoch, and then use that time function, that library that we loaded earlier, to convert that to hours, minutes, seconds, and so on. Put them on the serial port as well, just for fun. Why not? And then display whether the NTP update last worked, and that's it. So that's the code. You will find the circuit diagram in the manual. As said, the manual is loaded, is linked in the notes. Very important, because the manual is, as far as I'm concerned, everything for these projects. Even I won't remember what I did if I look at it again in 6 months or 12 months' time. So I open the manual and see, oh yeah, that's what I did, and this is why, and this is how it works exactly. All right, hope you enjoyed that little run through of yet another clock. Cheers and have a great day the rest of your day.